Why, hello. So what I'm going to talk about now is an example that helps with number 36 from section 3.4. In this section, we were finding determinants, and in 3.3, we were finding inverses. So what this example problem is meant to do is help us to get a formula for finding determinants, which doesn't require the row reduction. Now this is a bit more complicated in that there are several moving parts you have to keep track of, but it's something that you are allowed to use, and it's interesting. I'm going to do it with a different matrix A than in your problem. That way you can still apply it yourself and sort of see how this works. What is important for this one is a couple of things. We can use our methods to find out that the determinant of A turns out to be -2, and I trust that you're able to find that. I'll leave that as an exercise to the reader. But what's maybe new is this symbol right here, this A with a squiggle. So this is the cofactor matrix. So cofactor matrix is very much what we were doing when we were finding the determinant. And let me explain what that is. So in order to find the cofactor matrix, I would look at, oops, sorry about that, my original matrix and say, so what's going to be the top left element in my cofactor matrix? Well, in my original matrix, if I look at that element, cross out its row and column, I'm going to put in the determinant of what's left over here. So you multiply 4 and 3 and subtract 2 times 5. So that method that's very similar, very close to finding determinants, I'm going to use that to find this new matrix. So we just did 4 times 3, which is 12, minus 2 times 5. So that gives me here a 2. So 12 minus 10 is 2. Great. As I go along, I will also keep in mind this little checkerboard pattern that we also paid attention to when finding determinants. And this will apply to my new cofactor matrix as well. So the top left element is the positive version of what we get. So I do not change that too. But this next element right here, I will in fact need to make it the negative version of whatever I find. So it's going to be the negative version of whatever I find here. So let's do this. For this next element, I cross out its row and column, and I see that I have left a 2, 5, 1, and a 3. So I would take the determinant of that, which is 2 times 3 minus 1 times 5. So that gives me 1. So 2 times 3 is 6, minus 1 times 5 is 1. So I get 1, but I'm taking the negative version of it because it's in this second spot that corresponds to this position. And then we continue. So the next spot, top right, be the determinant of that smaller 2 by 2 matrix, so which is 2 multiplied by 2, and subtract 1 multiplied by 4. So we get a 0 in the top right. And we continue this on. In the second row of the first column, this 2, if I were to cross out its row and column, I would have left these 2 elements and these 2. So that would give me 2 times 3 minus 2 times 6. So that would be, in this case, right, 2 times 3 is 6 minus 12, so -6. But pay attention where we're at. We're right here. So we're actually going to take the negative version of this. The negative of a negative turns out to be a positive. So we get +6 in that spot right there. And then we continue this method along. So the middle space is going to be the positive version of what we get. Crossing out this row and column, we end up with -6. And we don't change its sign there. So -6. For the next spot, cross out its row and column, we have -2, but we change its sign to get +2. For the bottom space, cross out its row and column, take the determinant of this, which is 10 minus 24. So 10 minus 24 is -14, and we do not change its sign. This next spot, we will change its sign after we find it, so we cross out the row and column that corresponds to this next position, and take the determinant of what's left over, which has these two elements and these two elements. So that gives us negative 12, but we change its sign, so positive 12. And in the last space, we end up with a negative 4. So here is our cofactor matrix. This is the A squiggle. So we're almost done, except this tells me that I need to take, at the top there, the transpose of A squiggle, or the cofactor matrix. For some reason, A squiggle makes it sound more fun, though. Or A tilde, if you want. So to take the transpose, we leave the diagonal exactly where it is, and swap the rows and columns otherwise. So we get a 6, negative 1, negative 14, 0, 12, and 2. Great, so we're almost there. Our formula then tells us that the inverse of A is this right here, which was 1 over negative 2, right? The determinant of A we said was negative 2, times this matrix that I just found, 2, 6, negative 14, negative 1, negative 6, 12, 0, 2, negative 4. And it's a good thing to recall that when I multiply a matrix by a constant, that just means multiply every element by that constant. So I could simplify this down to negative 1, negative 3, 7, a half, positive 3, negative 6, 0, negative 1, positive 2. So there is the inverse matrix that we can get without doing row reduction using our formula. So let me zoom out just so we can see the whole process that we went through in sort of a smaller form. And there you have it.